This video, I'm going to go over problems from tonight's homework, chapter 9 and 10 review. I didn't do all of them, but I did do ones that I think that are good to look at. So the first problem is a polynomial inequality from chapter 9. You pull the 12 over to the left-hand side and change it to an equal sign. And then once you factor, you can set each factor equal to 0, and these are called critical points. You'll put those critical points on a number line. Now, on the final exam, I say to determine the shading, test the intervals. This is the example of where you test the intervals. You put in -7 or 8 or 9 or whatever, some number from the interval 1, and it comes out true. -7 is greater than -12. So I shade that region. Region 2, I picked -4, and you can see it came out false. Now be careful here when you plug in a negative, because it's -4 in parentheses squared turns it to a +16. In interval 3, I picked 0, and 0 is greater than -12, so I had a yes, no, yes. This is how you write it in interval notation. So Alex has you graph it on a line. I usually have you do both. So there's the number line and the interval notation. Next problem I did is from tonight's homework number 4. And here we have an absolute value inequality. Now, if there was anything added, subtracted, or multiplied, you would have to remove those over to the other side before you split this into two inequalities. So on this path, I just dropped the absolute value. So 2v plus 5 is greater than 7. But over here, notice I did two things. I flipped the inequality and I changed the sign. When I do that, I'm going to have an or because it started off as a greater than. You solve these separately by subtracting the 5 and dividing the 2. You have v is greater than 1. That's shaded over here. And then when you solve this one, you have v is less than or equal to -6, which is over here. And then you'll write this in interval notation from small to big. So -infinity to -6, that's a bracket because it's a solid dot, because of the or equal to. And if it were just a strict inequality, you would have an open dot in parentheses. The next one is a system of linear inequalities. And we treat these each separately and then darken the area where the two regions overlap. So the first equation I've numbered 1, and I put it here. You'll treat this as just a strict equality as you do the boundary line. So I changed it into the slope-intercept form, y equals mx plus b, and then I graphed that here, down 1, and then rise 2, run 5. And I think I got off on that a little bit. I was a little sloppy, but it's roughly in the right place. Testing 0, 0. So when I look at this point right here, relative to that boundary, 0 is not less than -5. So I don't shade the side with 0, 0. I shade down here. And that's these lines. Then the second inequality, I change to an equal sign, solve it for y, and I have down 2, and then I use the slope of down 2 over 7, and it gives me this boundary line, which is solid because of the or equal to. This one up here was dashed because of the strict inequality. So a dashed one on this one and a solid one on this one. You determine the shading by testing a point. If I can, I pick 0, 0. I plug that in here and I have 0 is less than 14. So relative to this line, this point here, 0, 0, did not work. So I shade beneath the line. Now what happened is the overlap was this triangle area here. And that's the thing you'll enter in Alex, but on the exam, this is kind of what your work will look like. Number 6 from the homework, this is still from chapter 9, was a graphing a radical. Now, first of all, if you know the shape, that'll get you a point. Knowing the transformations will get it all the way right. This is a shift to the right. So my leftmost point is at 8, 0. And I need to pick points that make these radicals come out easy. So if I pick 9, I would have 9 minus 8 is 1. Square root of 1 is 1. If I pick 12, I would have 12 minus 8 is 4. I picked that because 4 square rooted is 2. 17 minus 8 is 9. Square root of 9 is 3. And I didn't do that real precisely, but that's fine because I'm going to look at your t-chart. The domain is how far left and right the graph goes. This has a lower boundary that's hard, so I have a bracket at 8, and it goes off to infinity. Range is how far down the graph goes. Well, this is the y values. It goes down right here to 0 and then goes up to infinity. So notice you get the lower bound on the x and the y's from your leftmost point. Now we're going to switch over to chapter 10, which is radicals. This first problem is a little bit too easy for the final exam. I probably won't put anything this easy on there, but it's a good warm-up problem. 50, when you do its prime factorization, is 5 squared times 2. Remember, this is a square root, so we're trying to create perfect squares. So I'm going to pull the 5 out, and that shows up right here. And that 2, I circled it, it gets left underneath the radical. The t squared, there's 5 sets of t squared. Each one is a perfect square, and that comes out here as t to the 5th. But when I look at the w's, I have w to the 5th, or w to the 2 5 times, but then I have a leftover, right? I've got one more because it was 11 of them. So I circled it just to remind myself that leftover goes right there. And when you look at number 10, it ramps up in difficulty because it's a cube root. A cube root, you're going to create perfect cubes. So 2 cubed, x cubed, x cubed. That's what you're looking for, is cubes. So 16 is 2 times 2 times 2 times 2. Creating that perfect cube. I can pull that 2 out. Now don't lose the fact that there was a negative in front. This 2 gets stuck on the inside. X to the 8th, there's 8 x's. So if I wrote them all out in a line, I would have x, 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 8 of them. And then group up. Here's a perfect cube. Here's a perfect cube. And then here's what I think of as sort of the leftovers. So it's just like the numbers, create perfect cubes. 2 cubed, x cubed, x cubed. Those all come out front as a 2, x, x. So you multiply this x, x, and make it an x squared. The circled items are left over. I do a similar thing over here with 54, but I had to kind of remind myself what 54 was. It was 2 times 27, and 27 is 3 cubed. So 3 cubed is my perfect cubes. Just draw my arrow to remind myself it comes out. And it's multiplied by the 5 that's out there, so that's going to be negative 15. And then I have an x and an x, and then an x squared left on the inside. What happens after I simplify this 3 times 5 is I see that this pink highlighted area and this pink highlighted area are the same. And that's good because that means that they're like terms. Sometimes Alex makes them like terms, but not always. So just kind of be aware. That's a negative 17 when you add the negative 2 and negative 15. Number 13 is a multiplying a radical, and this is going to be a FOIL problem. So you're going to multiply this term times this term, the 5 times the 2, and then this one doesn't have a radical, so it's just going to be times square root of 6. 5 times 4 is 20. Now this one's the interesting one. The coefficients multiply. 4 times 2 gives you 8. And the radicands multiply. 2 times 6 gives you 12. So multiply the coefficients and the radicands. Now in the next line of work, I'm going to simplify because 12 is 4 times 3. Square root of 4 is 2. 8 times 2 is 16. But let's do the last one. 4 times 4 is 16 times the square root of 2. Now, this is the only one that simplified. Ended up that there wasn't any like terms. Okay, number 15. The problem starts right here, and this isn't simplified because we have a radical in the denominator. What we do to make that appear different is multiply by the number 1 in the form of 3 root 5 plus root 7 over 3 root 5 plus 7, root 7. It's the conjugate of the denominator. So this is a negative and this is a positive. When you FOIL this, what happens is outer and inner cancel, and then the radical will go away because you've got a perfect square here, which will be 9 times 5 on this next line of work. And then the radical here will go away because you have 7 squared square rooted, which becomes just 7. And then those like terms combine and you have a 38. On the top, when you did FOIL, you had this 3 times 5 is here. Outer was 1 square root of 35, and inner was 3 square root of 35, giving you 4 square root of 35. And then the last was just like down here, it was square root of 7 squared, which is just a 7. Now these combine, right? You've got a 15 here and a 7 here, which gives you a 22, and then 4 root 35. So you feel like you're almost done, but you've got 22, 4, and 38, which are all even, can be divided by 2. So down here is your final answer. Okay, Joe will have study sessions. Let me know if I can help at all. We'll talk to you tomorrow.